and today I'm going to talk about a strategy for integrating coding agents in the Eclipse space. So I think we've been seeing a lot over recently some the power of coding agents. Some of the use cases that we've seen demonstrated are being able to discover bugs, helping write code, including large, complicated refactorings, the ability to understand legacy code through code explanation, being able to review your code and generate documentation and tests. These things provide a lot of value to developers, making them faster, improving quality, and recovering lost knowledge from, for legacy code. That brings us to why we would want to add coding agents into Eclipse. Some of the reasons are that the agents can understand the full developer context and the full context that's present in their IDE, and it can not just advise but also take action, performing complicated steps. What we've been looking at in the Eclipse space is we've been building a prototype that builds off of two open source protocols. First is Model Context Protocol, which we've heard a lot about, and I believe I did a presentation a few months ago on that. But a more recent protocol that has come out at the end of August is something called the Agent Client Protocol. And this one standardizes the communication between IDEs and coding agents, where a coding agent in this case is a CLI coding agent like Claude Code or Google Gemini. I'm going to, summarize, since the ACP protocol builds off of Eclipse, I'm going to go over a bit what has been presented earlier about the Eclipse IDE and Model Context Protocol. We have an implementation that runs an MCP server inside the Eclipse VM. This grants it access to the internal state of Eclipse of the IDE, and allows it to interact with elements of the user interface. And we built a set of platform services like default MCPs that come with base Eclipse that grants agents access to the workspace resources, to editors, to consoles, as well as problem markers and so that you get compilation errors and to-do markers, as well as annotations within the editor. And then we worked with and experimented with features such as resource templates that let you kind of dynamically find and give you content assist to find resource that you want to add, and MCP tools with something called elicitation, which is also like a kind of content assist to help you retrieve additional missing parameters from the user when the tool is executed. We also added an extension point, so all the different plugins can contribute tools to the centralized server, as well as a set of preferences and tracing around the MCP stuff. So with this base Eclipse functionality, we can then add tools and stuff on top of that. Some of the benefits of having MCPs run inside the IDE is they have access to the secured storage, and we can apply vendor licensing enforcement on top of these. And they can interact with the state of the IDE and trigger user interface interactions. So this is a list of the default MCP servers that we have that are part of base Eclipse. So this just goes into we're using these open source libraries for the MCP SDK, and we're using annotation to decorate your Java functions with metadata for how MCP will work. We have a simple extension point, so plugins can contribute a factory for adding tools to the MCP server. The way that, so when you add these tools to the way that you implement these tools in your plugin is you just basically decorate a existing Java function. So here's an example of an open editor function. And you can see we add MCP metadata for what the name of the tool, its description, and then each parameter you can give those additional descriptions. And these plain language descriptions are used by the LLM to determine when to call these tools and how to dynamically figure out what to pass in as parameters. Additionally, you can have complex objects like this editor object here that's returned as output, as well as complex objects that are input. And those objects you can also decorate with Jackson annotations to further add, because we forward a full JSON schema to the LLMs. And yeah, so this is an example of a text selection object, and we provide additional explanation to the LLM so that it knows how to interpret this response object. And this is an example of the JSON schema that represents a tool called Open Editor. So you can see the LLM gets all this metadata so that it understands how to interact with a tool. When it comes to consuming these MCP tools, before this ACP protocol came around, we were thinking, how will people use these MCP services? So yeah, they can use them with standalone desktop apps outside of Eclipse. Terminal CLIs are a popular one. And then, they do have some options within the Eclipse space. There's Copilot for Eclipse, which supports MCP. And, they could also run a CLI inside the Eclipse terminal. So these are just some pictures of those. And here it is running in a terminal. But now we get to the agent client protocol. So this protocol, it was released in August by an editor called Zed Editor. Their initial CLI that was the reference implementation was Google Gemini CLI. And since then, since just August, there's been a lot of activity. So they've been, what this protocol does is it defines a contract between editors and IDEs on one hand, and then coding agent CLIs on the other hand, so that you can mix and match them fairly independently. Once the editor implements their client side, they can use all the agents that support that. And once an agent implements their side, they can be used in all these editors that support the client side. Recently, JetBrains announced that they're going to pivot to ACP for their whole suite of products. So yeah, this has a lot of momentum, and I'm going to show right now a quick demo of the Z editor, and the experience using that. So this is Z using, so let's start up a new Gemini CLI thread. And the first time you use this, it will install the NPM packages for Gemini in the background. And it may prompt you to log in with your Google account. And here I'm asking it just a simple command to add some HTML comments to this file, just so you can see the session took a bit of time. I just wanted you to see what the edit experience was. Sorry, there was a big pause here. All right. All right. So some of the messages that it sends is it sends you, as it's thinking, it sends you what its thought process is. I'm not sure why there was such a, okay, I guess this is an example of some of its thoughts. And it suggests a bunch of changes, and then you can approve the changes individually, or you can approve them or reject them en masse or individually. So yeah, I just wanted to show what the original sort of reference implementation was. So this is a rough sketch of kind of what the architecture is. So you have your IDE on your workstation, as well as the agent CLI. Your IDE may have some MCP servers running in it to say give it access to the console or editors. And then it has the ACP client running in it, which talks to the ACP agent running inside the CLI. During this initial handshake, the client forwards over the MCP servers, any MCP servers that it wants to, so the user doesn't have to manually go in and toggle with JSON to configure which MCPs it wants to work with. Yeah, and then the agent itself can talk to, it's large models. I suppose it could talk to, if users are worried about privacy, it could talk to a private version of that model, maybe on Amazon. Or in some cases, it can work with some smaller local models that'll fit on your workstation. This is what the protocol, the contract is between the client and the agent. So it works over JSON RPC. And I'll just cover some of the basics. So the first thing, that the client starts up the agent in a special mode and forwards, we'll forward over what features the client support. Like, do you support reading text files, or do you let the agent proxy terminal commands through it? And then the agent responds with things that it supports, like, do I support loading old user sessions? What kind of things can you include in the prompt? Can you include images or audio? What kind of MCPs do you support? They all support standard I/O, and then HTTP and SSC is optional, which means we may want to tunnel our HTTP over through an STDIO proxy to increase our coverage. At that point, once you're initialized, then there may be an authentication mechanism, typically OAuth. The client then calls start a new session. The session is basically a chat session. You may be able to load an old session There are different modes. If the agent supports multiple modes, you have the ability to set the mode. The prompt is when the user types something and hit enters, that's what triggers, that's the prompt message. And then there's a cancel message if users want to stop an in-progress thought process. And the agent sends back, a lot of the stuff comes through session update, which is where the thoughts come through, as well as the end message. It may request permission for certain operations at some point. The built-in read and write is implemented as kind of a buffer system where editors can represent like dirty buffers, unsaved changes. So if there's an open editor and they're trying to read that file, you return the editor contents, even if it's dirty, and you can write to that open editor. If there's no editor open, then you can work with the raw files underneath. And then there are some services, which I haven't really looked at. A lot of these agents can run their own terminal commands, and I guess maybe this is for some agents who don't have that and want to use an API instead to do that. So we've been working on an Eclipse implementation of this ACP client that adds an agent chat experience on top of ACP, starting with Gemini CLI. And yeah, we implemented or are planning to implement, these various features such as the chat lifecycle, the user prompt lifecycle, forwarding the MCPs to automatically configure them, tool use confirmation, read write, embedded and reference resource links within the prompt, keyboard shortcuts and actions to select the file and add it to a chat. So this is a screenshot of the chat. We've gone with using the embedded SWT browser as the presentation framework. This is because there's just a lot more. So the default expression language that the chat returns to us is Markdown, including, Markdown code blocks. And there's just a lot more support for these sort of transformations in the HTML, JavaScript space. We are trying to style it and make it behave just like a regular Eclipse widget. But yeah, it does do Markdown transformation. We figured out how to pipe in images as base 64 strings, so we can, the icons associated with different files can come through nicely. So an overview of sort of the architectural setup is we are using LSP for J, though we did have to customize it, their version of JSON RPC, which is what is powering all the LSP functionality. Though we did have to modify a bit because that's customized for the HTTP flavor of JSON RPC, and this is just a standard IO flavor, which also uses JSON for its Java version of JSON parsing. On the UX side, we're using the SWT browser. So there's a translation between the Java runtimes and JavaScript runtimes, and we can send messages forward and back. We are forwarding over, the Eclipse theming, fonts and colors into CSS variables. For now, we're using web components in just plain JavaScript. So I've been just learning about templates and shadow DOMs. And for the Markdown stuff, we're using some libraries to transform those into HTML tags, and then using another library for styling the code blocks. So it won't be the LSP stuff that's doing the styling initially. And then maybe we'll look at diagramming stuff like mermaid diagrams. an example. So I'm going to select to use the so I guess on the first demo, I will say add these to chat, and I will just ask to explain what these files do. And, we can see, I can click on these to open the individual files. The icons from this are translated through to the HTML layer nicely. Its thoughts are sort of, I can open them up and see what it's thinking as it's analyzing. They shouldn't be, they should be joined into one. I'm not sure why they split. But after it's done its full analysis, it'll come back and say, and here you can see, what the communication looks like under the covers. So these are all just JSON RPC messages. So yeah, it comes back with the explanation. Another example, I can do like large, I can do like, let's see if I can do a refactoring. So I can add this to my project, to my chat, and say, change the package to my.plugin.project.editors. Oops. My rate limit has exceeded. Okay. That's always fun in a demo, but I do have, let's see, I'll have this backup demo. This demo is going to demonstrate a scenario where I use a DB2 MCP to generate some SQL stuff. This is an older version, so it'll be a little rougher in the UI, but it's going to, so I'm asking it to create a view statement that returns the union of 3 inventory DB2 tables. And this one took a lot more, it needed a lot more guidance this time. But here is, it's asking permission to edit a file. And in this first attempt, it didn't even look at the database, which it usually does. But I'm going to further give it guidance to actually go look at the DB2 tables. So here it's calling the DB2 list tables tool. It's found 3 tables that have INV and TRY in them. So it assumes those are the 3 inventory tables. And then it pauses, waiting for me to say, go ahead and use those tables. So it updated the tables in the editor, but I really wanted to list all the columns out explicitly. So I am giving it further direction. You can see in the editor that it's added all the columns. I'm asking it to create a drop statement at the beginning. I'm asking it to add some SQL comments. Now I'm asking it to run. So I just deployed the view, and now I'm asking it to run a SQL statement that selects the contents of the view inventory view. And it needs access to another run SQL tool. Processing the data, and then it will print it out in Markdown format. Okay. That is my presentation, and we can open it up for comments.